today we are going to actually learn about nucleophilic substitution mechanism. Nucleophilic substitution mechanism happens for halogenoalkanes, and we have SN1 and SN2 mechanism. So if we look at the SN1 and SN2, the reason why they give the number 1 and number 2 over there, it's because of there are going to be one reactant at the rate determining step, and rate determining step, okay, we are going to learn under A2 later, okay, which is going to be, it can be also be defined as a slow step. Okay, so under the rate determining step or the slow step, there is one reactant involved, and here under the rate determining step there are going to be two reactants involved. Okay, so if we have an example, okay, if I just take a simple example, if I have, for example, this molecule Cl is being actually reacted with the nucleophile OH, and what are we going to get? Okay, we supposed to know that this OH minus, okay, is going to actually replace or substitute the Cl to give you this molecule. Now we need to find out now the mechanism or the steps, okay, how they actually, this reaction actually go through, okay, how it can go through. So we actually can show the mechanism by two ways. Okay, so I'll just put it as way number 1, and let's look at it as way number 2. So the way number 1, okay, is going to be by having something like this, RR, and then the Cl being more electronegative, they will withdraw the electron towards the Cl, making it more partially negative and partially positive. And what will it do? It will make the molecule to change into a carbocation. Heterolytic fission is going to happen, and you are going to get a nucleophile over here, okay, and a carbocation over here. Now let's not forget about there is going to be a substitution with this OH minus. If you look over here, the OH minus nucleophile is more stronger than the Cl minus nucleophile. If it is not strong, then there is no reaction that's going to take place. So therefore, this nucleophile is going to attack the carbocation, and you are going to get this molecule. And then Cl minus. Okay, this is going to be the first way, and you can actually just put it as slow step, and this is going to be a fast step. Now if I change this molecule, okay, let's say we look at a different way of the reaction can take place. You can actually have something like this, Cl, but now, okay, let's see, we just put the nucleophile over here. Now similar thing is going to happen. Chlorine is going to be more electronegative. It will withdraw the electron towards itself, and what's going to happen, the OH nucleophile is going to attack the carbocation, it will go and attack the partially positive carbon, which is under the halogenoalkanes. So what is going to happen is going to be, you are going to get an intermediate. So if I draw the intermediate, it will be something like this, Cl, OH, and R. Okay, and if you can see clearly over here, there are going to be the dotted line over there to indicate that, okay, this bond between the C and Cl, they might actually break anytime soon, or preparing to break. And this bond between C and OH, they are kind of forming, so they are in some kind of intermediate form, so they will form intermediate. And what's going to happen next? Immediately the bond will be broken, so you are going to get carbon. Okay, I'll just draw it this way, R, OH, and then you have the Cl minus. Okay, this is going to be the step, and it's not correct to actually say that this is going to be slow or fast, but if you want to put it, maybe we can just put it slow. This is not fast, okay, it just happens immediately, so it's not fast reaction. So there is going to be the slow step here, and there is a slow step here. And according to the definition earlier, I was actually telling you about the SN1 and SN2. You can see the rate determining step, or the slow step, okay, the slow step. They have, for SN1 they have one reactant, and for SN2 they have two reactant. And if you look at the mechanism 1 and 2 over here, we can see that for the slow step, okay, we only have one reactant. For the mechanism for the second reaction, you can actually see that there are two reactants over here, reactant 1, reactant 2. That means that since it has the one reactant for the slow step, this is going to be SN1 mechanism. Because you have two reactants over here, that's going to be your SN2 mechanism. So in summary, okay, what can we say about SN1 and SN2? SN1, okay, SN2, you can see SN1, they have tendency to form a carbocation there. So I'll just put it, okay, they have tendency to form carbocation. But for SN2, they have tendency to form intermediate. So intermediate form. So this is going to be a rough idea about to show you about SN1 and SN2 mechanism. Okay, SN1 and SN2 mechanism. So which of the halogenalkane will follow SN1? Which of them will actually follow SN2? To answer this, it got to do with Markovnikov rule. Okay, you need to actually look at the Markovnikov rule, where they say that tertiary carbocation is more stable than secondary carbocation, and secondary carbocation is more stable than the primary carbocation. It means that if you have a primary halogenoalkane, a primary halogenoalkane is going to be, this is going to be a primary halogenoalkane. A primary halogenoalkane, once they actually form, let's say there is going to be a break, a fission over there, they are going to give you a primary carbocation. Okay, they are going to give you a primary carbocation. If let's say if you look at the tertiary halogenoalkane, C, R, and then you have Cl, they are obviously going to give you a tertiary carbocation. Now, we need to understand that according to Markovnikov rule, he mentioned that a primary carbocation, or the tertiary carbocation, is more stable compared to secondary and primary carbocation. So if you have a tertiary halogenoalkane, the tertiary halogenoalkane will have tendency to form a tertiary carbocation, which is more stable. So if you have this molecule over here, you can clearly see that there is 1R group, 2R group, and 3R group. Obviously this is going to be a tertiary halogenoalkane. They will have tendency to form a tertiary carbocation, which is this carbocation is much more stable. So tertiary halogenoalkane will tend to form a tertiary carbocation instead of forming intermediate. Why they want to form the intermediate? Where they can actually reach a carbocation which is more stable. Therefore, tertiary halogenoalkane tends to form carbocation, and they tend to follow a mechanism that will form carbocation. Therefore, they tend to, for this reaction, for this particular reaction, they tend to follow SN1 reaction or SN1 step, because carbocation is going to be formed rather than going through SN2. So if you change this mechanism, let's say for example we are talking about primary halogenoalkane, and primary halogenoalkane, they have tendency, so if I just change this a little bit, okay, if you change this into primary, now primary halogenoalkane, if they actually form a carbocation, they will form a primary carbocation, which is not stable. They tend to actually form intermediate. So they tend to go through SN2 mechanism to form the intermediate. So they tend to follow this reaction. So they will follow the intermediate, form the intermediate. So if I just make it correct over here, okay, that's going to be only one R group, so I just draw H and H. The rest is the same. Okay, maybe here H, H. The rest is the same. So in summary, if we look at SN1, if we look at SN2, okay, carbocation will be formed for SN1. Intermediate tends to be formed for SN2. So for SN1, okay, tertiary carbocation is more stable. Therefore, tertiary halogenoalkanes tend to actually form carbocation, tend to actually follow the SN1 mechanism. For primary halogenoalkane, they tend to form intermediate rather than forming a carbocation. Therefore, they actually tend to follow the SN2. So if in summary, if you ask how about secondary halogenoalkane, what they will follow, they can actually follow either SN1 or SN2. Doesn't make any difference. So this is the summary of today's lesson. Thank you.